So we started our week talking about the division of decimals, and we came at it strategically at first, and we looked at it and we said, as long as our divisor can become a whole number, that we are able to use the standard algorithm to divide. So for example, when we look at this particular problem, 1 5/10 needs to become 15. So we can multiply it by a power of 10, multiply it by 10, or simply move the decimal to the right one place. Well, in order to keep the quotient the same, or keep the quotient equivalent, we need to do the same to the dividend. So we're going to take and move this decimal in the dividend to the right one place, or we can say multiply it by a power of 10. Once we've done that, we're able to set up our standard algorithm and complete the problem. Just be mindful that the goal is not to have both the dividend and the divisor to become a whole number. It's simply to make the divisor a whole number, and in doing so, we need to adjust or multiply um, equally in terms of by powers of 10 so that we don't impact our quotient. Once we've set this up, now our new dividend is 201 and 75 hundredths. I'm going to put this inside of our quote unquote box. I know it's not a complete box. And then 15 on the outside. And then ultimately, we begin going through a process where we're really kind of cycling through the same questions and operations. The initial thing is we're going to find one of the opening digits to take 15 out of. So we're going to look at the 2 and ask ourselves, can we take a group of 15 out of that? And we cannot. So we're going to expand to the right one place and look at 20. And can we get a 15 out of 20? And we can. We can take one group of 15. That becomes a division that leads to multiplication, because I'm going to take that 1 and multiply it by 15. And then I'm going to subtract, and at that point, I'm going to begin this looping process. I'm going to divide, multiply, subtract, and then repeat. When I repeat, I'm going to drop a digit in the remaining numbers in the dividend, and then continue to do the process. And I'm going to highlight where my eyes are focused on. So in this particular problem, now I'm looking at 51. So I'm going to say how many groups of 15 can come out of 51, and I could take 3, because 3 times 5 is 45. And then again, I'm just that process, then subtract, and I get 6. And then I'm going to drop down the 7. And what I want to do here is I'm going to stop and make sure that my decimal comes up from the original problem or the original dividend into the quotient, so that I don't lose sight of that as we go. I'm going to continue once I've subtracted, dropped a number or a digit. I'm going to say now, how many groups of 15 can I get out of 67, which is 4, because, oops, 4 times 15 is 60. Find the difference, and that's 7, and then drop my last digit, which is a 5, and I know that I get 5 groups, because 5 times 15 is 75, and at that point, I have completed the problem, because I hit a 0 at the bottom and there's no other digits to drop. And if there were digits to drop, I could continue to drop them, but I don't. So my final answer is 13 and 45 hundredths. So after we looked at division on Monday and Tuesday, we transitioned into some real world applications on Wednesday and Thursday. Our first stop on Wednesday was looking at sales tax and how it impacts the cost of what we might purchase. And it's an opportunity to take a percentage of a total, or a part of the total when the percentage is less than 100. And so we began looking at really something that's very common to us, and looking at the sales tax on something that we purchased. And so I took a little virtual trip to the Apple store, and we took a look at buying some new toys for Mr. Elliott. But we one of the things we explored was looking at a new iPad, and the question was, can we walk out of the Apple store only paying $599? And the question was no, or the answer, I'm sorry, was no, because we have to actually pay tax on top of that. So we looked at what are the 2 steps required in order to calculate the total cost. So the first step is we need to calculate the tax involved in purchasing the iPad. So in doing that, we need to take the product cost, which in this case is $599. And for this cost, I'm going to leave the zeros off because I don't really need them right now. So I'm going to say $599, and I'm going to multiply it by 0.06, which is 6%. We talked about that. How do we compute that? And basically, we're multiplying that by 1/100. So it's 6 parts of 100 is what this percentage is talking about, or we could call that 0.06. And so we set up our standard algorithm. We pull our decimals out, which is our strategy. And we do 599 times 6. So I know 9 times 6 is 54. I'm regrouping. And then I would get 59. I'm regrouping again. And I would get 35. Now at this point, 599 times 6 is 3,594. But I noticed from above and then strategically, I have 2 places to the right of the decimal. And now it's time to put those back in. Again, one of the things that we've been practicing is we don't want to put our decimals into the algorithm just out of fear that it might confuse us in terms of how we line that up. So we write that original problem, from left to right, and then at the end we go back in and put the decimal in, just as a safeguard not to do that. Now what we learned from this is that the tax on the iPad is $35.94. Well, that's not all of it. I wish I could go over there and only pay $34.94, but Apple wants its money as well. So now in calculating the total cost, I'm going to add those two numbers together. So now $599 plus $35.94. I add those together and get 9, bring my decimal down. Notice again with addition that our decimal is lined up by place value. All digits are lined up by place value. And the final cost of the iPad with the 6% sales tax would be $634.94. Once we finished up looking at our first real-world application of decimals and operations in a real-world scenario, then we pivoted and took a look at averages. And so we determined that an average is a central value. It's an expected or anticipated outcome based on looking at a set of data. And so being provided a set of data as such here, we've got test scores for student A. We're going to take a look at these 4 test scores and determine what is the average. And what that could tell us is a couple things moving on. And honestly, the more data we gather, we could actually learn a little more about it, which is something you'll dive into later on in your math careers and statistics. But you'll be able to become a little bit more predictive with it. But for all intent purposes, we want to look at how to calculate the average. And so the first thing we need to do is take our given set of data, and we want to find the sum of all data points. So for this particular problem, they're all whole numbers, so we're just good to line them up by place value. And notice again, I want to always point out just some of the, I think, helpful mechanical strategies is that I would make sure that every digit is in a box and it keeps things lined up vertically. And so I've lined them up, 10, I've got 15, regroup the 1, 18, looks like 36. So my total sum of my data points is 365. In order to find the average, I want to take that sum and I'm going to divide by the number of data points. I have 1, 2, 3, 4 data points, so I'm going to divide by 4. I'm going to apply those same rules. I'm going to first look at 36, and I'm going to take 9 groups of 4 out. Take 9 times 4 is 36. I have a difference of 0. I can drop the 5 and take 1 group out of the 5, and that would be 1 times 4, and it gives me 1. Now, my tendency might be at this point to have a remainder 1, but we talked, the remainder is no more. We are now, because of our understanding of decimals, we're able to add a decimal, and I'm going to go ahead and add it to both the dividend and the quotient. And I'm going to extend my line, add a 0, and then continue the process. So I'm going to add a 0, which will drop that and give me a 10 to look at. How many groups of 4 can I take out of 10? I can take a 2, and then 2 times 4 is 8. And then at this point, you're starting to see why the standard algorithm was kind of coined the term long division. So I'm going to expand my page just a little bit to give us a little more visual room. 10 minus 8 is 2. Because I'm not at a 0 as that difference, I have to keep trucking along. I can add another 0. I'm going to extend my line, add a 0, and drop it. And so my new number to look at in groups of 4 would be 20. I'm already thinking ahead. I can get 5 groups out of 20. So 5 times 4 is 20. And I finally found that 0. So what I know is that based on the test scores provided, that the central value based on this set of data, and again, it's not the center number or the middle number, but it's a central value, would be 91 and 25 hundredths. And that would be our average. So again, with the process is find the sum of all data given and then divide by the number of data points. And so that was average. So this is a quick recap of what we did this week. Best of luck as you prepare for our quiz tomorrow. Thanks, and I appreciate you taking time to watch.